All right, let's do a little bit about pointers and pointer arithmetic. So let's get started with what's been declared here. So if I take a look here, I have declared 3 pointers, IP, KP, and MP, but they don't point anywhere yet. So I have IP, which is ready to point somewhere, KP, that's ready to point somewhere, and MP, that's ready to point somewhere. But I do have an integer variable x, which is right here, which has the value of 10. I also have an integer variable y, I have an integer variable z, and an integer variable h. Now I also have an array, AR, which is going to point right here, and it has 7 items. It has 2, 4, 6, 8, 3, 5, and 7. So this is AR at index 0, AR at index 1, AR at index 2, AR at index 3, AR at index 4, AR at index 5, and AR at index 6. So everything that's over on this side is an integer, and everything that's over on this side is an address of an integer. So I have IP, which is an address, KP, which is an address, AR, which is an address, and MP, which is an address. What does that mean? They're all pointers. So now I can take a look at what these say. IP equals address of X. So if X is located here, right here, this is X's address. So IP is going to point at that location. Then I say KP equals AR plus 2. Well, since AR is an address, when you say plus 2 to an address, you don't actually add 2 to it, you add 2 size of integers. So if however many bytes an integer is, basically you would just move in memory 2 integers. So if KP is going to start at AR and then go down, let's change the color here. Somehow I'm going to get that color thing to come up. There it is. Okay, KP is going to start right here, and then it's going to go 1 integer, 2 integers. So then KP is now going to point right here. So this is actually now going to be the value at KP. It's AR2, but it's also the value at KP. This variable right here, the 6. And this X is also the value at IP. All right, so let's see MP. MP is going to point in the same place as AR. So this 2 right here could be AR at index 0, value at AR, and it could also be value at MP. All right, so now that we've done that and we've pointed our pointer somewhere, now we can see what this says. So let's see what this means. This right here, the star, says go to IP and take the value at IP and assign that to Y. So I go where IP points, go to the value at IP and assign that to Y. So then Y is now going to be 10. And here I have to go where KP is located, add, these parentheses are very important, add 1 to it. So go where KP is located, add 1 to that, which is right here, which is going to be this one right here, and take that value. So Z is going to have this value right here. I went where KP points, which is right here. I added 1 integer to that, and I went down here. So right here, this is what I'm going to assign to Z. The 8, which is where I look at where the parentheses are. Go to KP, add 1 integer to it, and then take the value at that. Now this is very different. I go to MP, take the value at MP, and then add 1 to that value. So if you notice where the parentheses are is very important in the placement of the parentheses. This is pointer arithmetic. This is just adding to an integer. So I go where MP points, and MP points right here, and that's a 2. Then I add 1 to that 2, and I assign it to H, which would make it a 3. Now another thing that you can do is you can do something like this, and I could say MP equals MP plus 4, for example. So what that would do is it would take MP where it points, move 1, 2, 3, 4 integers, and then MP would no longer point here. MP would now point here. So this 3 then would become the value at MP, or also the array at index 4. So I hope that clears up a little bit about pointers and pointer arithmetic and pointers and arrays, and I hope that helps.